this week, you're going to learn all about logical functions in Excel, in particular and, if, and or. I'm then going to teach you advanced logical functions, such as count if, sum if, and average if. I will remind you of flash fill, and I will explain some of the limitations related to flash fill and how you can overcome those challenges with text functions. You're going to learn the basics of financial functions in this week. I'm going to explain how to make named ranges dynamic. I'm going to explain kind of why you want to do this and what the advantages of doing this are. If you want to work along, I have this in a file called dynamic ranges. I've got maybe some weights here of some object. We can easily calculate the average by just typing in the average function. I can also type in something known as a standard deviation, which gives us kind of a measure of the variability. We can calculate the maximum of that range and also the minimum of that range. So a lot of this, perhaps other than the standard deviation, you guys were already aware of. You see in here I've referenced A2 to A8. In general, it's a good idea, instead of using ranges like that, to just name this. And so we can name a range by going up here to the name box. I'll just call this weights. So now the average, it's better in general to use named variables, just so you don't get confused. So I'm just going to replace all the ranges I had in these formulas with our named weights array over here, and we're all set. So for example, the minimum, we're taking the min of the weights. One of the nice things about named ranges is if we insert, so let's say I insert a cell by shifting that down, and maybe I put in a new value here, 29.8. You see that the average, so let me do Control Z. You see that the average and all of these things update. So when I do Control Y and toggle between, they update. If I go up here to the name box and I type in weights, it updates if you add something in the middle of it. However, one of the main disadvantages, if I add something to the bottom here, 31.3, you see that it's not updating that. So let me do Control Z, Control Y, Control Z, Control Y. You guys can see that these are not updating. And furthermore, if I type in weights, it's only recognizing those initial ones. Again, I can add in, I can insert, shift them down, and I can add in another value, and that's incorporated into our weights named array. So the question arises, how do I get this last one that's entered, 31.3, to be included in my average, standard deviation, max, and min calculations? Well, I'm going to show you how to do that here. In order to do this, it's known as dynamic naming of ranges. We first have to understand something known as the offset function, because we're going to use that offset function in the way that we do that. So the offset function, the important thing about the offset function, it always returns an array. So that's like the most important thing that you need to remember. We always start, the first argument is where you start. So if I were to start at this point, F3, that's sort of our starting point. The second argument is the rows from that starting point that we want to begin our array. So if I wanted to make an array of cells G5 through H6, then I'm going to offset 2 rows and 1 column. So starting in F3, if I offset 2 rows and 1 column, I'll be starting in G5. if I wanted to output G5 to H6, that would be a 2 by 2 array, so I can put a 2, comma 2. The newer versions of Excel, you can just press enter. Otherwise, what you'll have to do is you'll have to highlight a 2 by 2 array before you do that. We're going to use offset. We're going to start at cell A2, and in fact we're going to make that an absolute reference, and we're going to offset by 0, 0, because I want to start in A2. I don't want to offset by anything. And then we're going to create an array. Remember, we're creating a weights vector, and it's going to be size. Now, this is the important part. We want to make the size dynamic. So we're going to count the total number of items in column A, and we're going to make sure we're not counting that top one. I'm going to use the count function because the count function ignores text. So I'm going to count, and I can do columns A. I'm going to make that an absolute reference. Alright, so here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and it's not going to count that top one. So the array that's going to be output by this offset formula is going to start at A2. It's going to have height of 9, and we want to make that a width of 1. And so that's what this looks like. If you add something to this, you see that it automatically updates down here because we use that count formula up here. Alright? So I'm going to go ahead and just copy this entire formula. Make sure you're not just copying down here, but go up here and manually, so highlight that, right click, copy, and then press enter. And now I'm going to go up to the name manager, and for weights, I'm going to edit this, and here in the refers to, I'm just going to do my control paste. Make sure all the references are absolute, otherwise it tends not to work. And then I can press OK, press close, and now I'm just going to delete this test array over here. And let's make sure if we delete this 31, you see that it changes. I can add different elements to here, and it's automatically updating. Let's make sure the max updates. If we put a 70, it's updating, and if I put a really small number, it's updating there. Oftentimes you want to use dynamic ranges for various things. We'll encounter a couple more examples in this course. Cover some more advanced logical functions in Excel. I'll be working on this cookies file over here. I've added in a column here for sales. That's just the product of quantity and price. And we're going to do a couple things. The first thing we're going to do is we're going to tally the number of sales for each of the unique sellers. Now here in column A, we've got repeats. So I'm first going to show you 2 ways in which we can eliminate duplicates. So I'm going to go ahead and copy over here. I'm going to just paste. And then what I'm going to do is go up here to the data tab, and up here, and you'll learn more about this in week 4. Go up here, and I'm going to remove duplicates, and we're going to select column H, and what that does is it found 6 duplicate values, 5 unique values remain. If we wanted to sort that alphabetically, I could go in here, I could go up to the home tab, and I can sort and filter, sort A to Z. So that's one way we can do this. We're going to calculate the number of sales. That's going to be the total number of sales for Charlie, Dana, Ella, Ezra, and Max. And then we're going to sum the total sales here. To do this, there is a COUNTIF function in Excel. This first argument is the range that we're going to count. So we're going to count this range here, and I'm going to press the F4 key there to make that absolute. And the criteria, we're going to look through the range there, A2 to A12, and we're going to look for Charlie here. So I'm making that a relative reference. So now it's going to do that, and Charlie has made 3 different sales there. Because I had the absolute reference there on the range and a relative reference on the person to the left, I can just drag this down. And that's a good way that we can determine the number of sales of each of our sellers. We can also calculate total sales, so I can type in the Sumif function. The first argument is the range that we're going to be looking for the criteria, the second argument in. So I'm going to press F4. The criteria is I'm looking for Charlie, and that's going to be relative, and then the sum range is if it's different from the first range, which obviously it will be here because we're not summing names, we're summing sales. So I'm going to put that in. I'm going to make that absolute reference, and then I can press enter. That means that I have had $62 of sales. I'm going to go ahead and make that accounting up here, and then the way that I typed in my formula, I can drag that down. So this tells us then the total sales and the number of sales of each of the sellers. Maybe we want to put together a cookie summary, and again I can go over here to the cookies and I can copy and I can just paste, and then I can go up here to the data tab and I can remove duplicates. Select column H there. 8 duplicate values were found and removed. 3 unique values remain. So those are the 3 different cookies. Let's make this a little bit bigger. Let's make this bold. And now I'm going to determine how many boxes of each of these were purchased in sum. So I'm going to do the sum if, and the range I'm looking over, I'm looking for the match of the cookies in column C. I'm going to go ahead and make that absolute. The criteria is it has to be in this first row, choco chip, and then the sum range I'm looking over. I'm not looking at the total sales, I'm looking at the total quantity. So I'm going to be doing that, make that F4, and then I can press enter, and we can drag that down, and those are the numbers of boxes of each of those that have been sold. Now what if I wanted to determine 2 simultaneous if statements? We can use a new function. So this is new only in Excel 2019 and Office 365. There's a Sumifs function. I'm just going to go over a couple of simple financial functions. Just a couple examples. You borrow $20,000 to be repaid using a common 15-year payoff period. Your loan charges an annual rate of 5%, compounded monthly. What is your monthly payment, and how much did you pay for your loan? Maybe you deposit $5,000 into a savings account. It pays 2% per year, compounded annually. If all of the money is allowed to accumulate, how much will you have in 10 years? Last one, if you want $20,000 in 5 years, and you can make payments of $200 each month with an annual interest rate of 3.5%, how much do you need to put down today? So I'm going to show you how we can answer these questions using Excel. So Excel's got lots of financial functions. What's nice about Excel for financial calculations is not necessarily the functions, but financial functions certainly help you, but also the organizational aspect of Excel is really valuable. We're going to talk about the payment function, PMT, the future value function, FV, and the present value function, PV, in Excel. The PMT, or payment function, calculates the periodic payment for a loan, and it has 3 required arguments: rate, N per, and PV. There are 2 optional arguments indicated by square brackets. The rate is the interest rate. If it's an annual percentage rate or an APR, be sure if you're making monthly payments, if it's compounded monthly, that you're dividing by 12. NPER is the number of payment periods. So if you're doing a 15-year loan, and you're paying monthly payments, then the total number of payment periods would be 12 times 15, or 180. PV is known as the present value, also known as the principal. FV, future value, that's optional. It's the future value that you'd like the loan to have. The default is 0, but it certainly doesn't have to be. And the type is usually 0. So it's 0 for payments due at the end of period, 1 for payments due at the beginning. It's really important to note that anything you get from a loan or a bank is a positive monetary value in Excel's financial functions. But anything that you put towards your loan or into the bank is going to be a negative monetary value. So let's work through this first example. You borrow $20,000, so that's going to actually be your present value or your principal, and that's out of the bank, so it's going to be positive. To be repaid using a common 15-year payoff period, your loan charges an annual rate of 5%, so the annual rate is 5%, but it's compounded monthly. And the question is, what's your monthly payment? And overall, how much did you pay for the loan? I've got this starter file available. The first question, we are basically asked for a monthly payment. So if you're asked for a payment, you're trying to solve for a payment, you probably want to use the payment function. So I'm going to put in PMT. The first argument is our rate, which is our annual percentage rate divided by 12 because we're compounding monthly. The number of periods is going to be the number of years times there's 12 months per year, so you have to make sure you're multiplying by 12. The present value of the loan is how much we took from the bank, which is $20,000. The fourth argument here is the future value. After we've paid off this loan, we want that to have a value of 0. So you can either enter 0 or you can just leave it blank. And in all of the examples that I'm going to be doing, the type is going to be left off because the default is 0. We make the payments at the end of the month. So when I press enter, we see that we have a $158 in parentheses. Make sure that if you're working with currency, you've got this $sign selected and you have currency. So anything in parentheses means that it's a negative amount. Negative payments mean that you're paying the bank back. So every month you're going to have to pay the bank $158 for the next 15 years. Now the total paid, we have 12 months for 15 years. That's a total of 180 months. And we're going to multiply that by, I'm going to do the negative of the payment just to make this a positive number. So we have paid $28,500. To calculate the total interest that we have paid the bank, we can subtract from the total that we paid the bank over those 15 years the initial loan amount that we got of $20,000. So over those 15 years, we've paid the bank nearly $8,500. Now, if you need to calculate the future value of an investment, whether or not you have payments, you can use the FV function. The FV function has 3 required arguments. We have rate, number of periods. The third argument is payment. So this is the payment made each period. Now, if it's omitted, you have to provide the fourth optional argument. So a lot of times you're not making payments on a loan. Maybe you're just putting a one-time amount that you're going to invest. And so sometimes you don't have payments. If you leave that out, then you need to provide the present value. So I've got an example here. You deposit $5,000 into a savings account that pays 2% per year, compounded annually. If all the money is allowed to accumulate, how much will you have in 10 years? So working over here in Excel, I can put the present value. So this is actually a savings account. So anything we put into the bank is going to be negative. Now this is negative 5,000. The interest rate is 2% per year, and we're going to compound annually. So that's a little different than the previous example. If all the money is allowed to accumulate, how much will you have in 10 years? So we can use the future value function. the rate is going to be 0.02. Now I'm not dividing by 12 because we're compounding annually. The number of periods will just be the number of years and the payment. So we're not making payments to this account, so that's going to be 0. Now remember, if you put in 0 for the payment, then the fourth argument is required. Otherwise, you're not investing anything or you're not putting any payments into the bank. So I'm going to put in that present value of our savings, and then I'm going to press enter. So that means that the future value after 10 years, $5,000 will become about $6,100. And the amount earned, we can just take our future value and we can subtract. I'm adding a negative number just to get the difference there. That means we will have earned about $1,100 in 10 years. The last financial function in Excel that I'm going to talk about is the present value function. So this calculates the present value of a loan or investment, and it's got similar arguments. It has the rate, it has the number of payment periods, it's got the payment that is made each period. Again, if you omit that, then you have to provide the future value. So let's go through an example here. If you want $20,000 in 5 years, so that's going to be a future value of positive $20,000. And if you can make payments of $200 each month, so those payments are going to be negative, with an annual interest rate of 3.5% compounded monthly, how much do you need to put down today? So we're trying to calculate how much to put down today. That's a present value. And if you're putting it into the bank, it's going to be a negative number. So in Excel, I can put my future value. My annual percentage rate is 3.5%. I can make a payment of $200 a month, so that's a negative value. And then I can calculate the present value. So this means how much I need to put down today in order to get that $20,000 in 5 years, making $200 payments every month. So the rate is going to be our annual percentage rate up there divided by 12. The number of periods is going to be 12 times the number of years. The payment I can make is right there. It's our $200. And then the future value, I want $20,000. So when I press enter, this means that I need to put down about $5,800 today. So that's just a brief introduction to the financial functions in Excel. Or I've got this spreadsheet that you can work along with me if you'd like. So the first thing I'm going to talk about is an if function. The if function in Excel basically tests to see if a condition is true, and then it can do one of two things. If that condition is true, it can do one thing. If that condition is false, it can do another thing. I'm just going to start by typing in a quick example. So I type in if, and then that's our logical test goes first. So what I'm going to do is I'm going to check to see if the cell next to it is equal to 3. So this first argument of the if function has to be some sort of a conditional expression. Now let me back up. Let me just show you a couple of these conditional expressions. So I could do something like 4 equals 5, and that's going to be a false. I could do 4 equal 4, and it's going to be a true. So essentially with these conditional arguments, we're asking Excel if that conditional is true or false. We can also do less than. So is 4 less than 9? That's true. Equals 4 greater than 9? That's false. And so conditionals usually have equal or less than signs, less than, equal, greater than, and so on. So let's go back here. I'm going to do if. My conditional is going to be if the cell next to it is equal to 3. The second argument of the if function is what do we want to be in that cell if the value is true? And I'm just going to say 50. So if we have a 3, we're going to put in this cell a value of 50. Otherwise, we're just going to put in 0. Alright? So obviously, let's double click in here again. Cell B4, which is a 1, is not equal to 3. So then we don't do the second argument, because that's if it's true, if that conditional is true. So we do if that conditional is false, and we put a 0 in there. Now if I drag this down, same thing. 2 is not equal to 3, so we're going to put a 0 in there. But the next one, B3 is equal to 3, and so we're going to put a 50 because our conditional is true. Alright, so then I can drag this down, and that's how we can do a simple if function. Now we don't have to return values, so I could do something like if this, I'm going to refer to that column B again, equals 2. So if that's true, we can put strings in here with quotations. So I could say something like equal to 2. Otherwise, if this, I'm going to refer to that column B again, equals 2. So if that's true, we can put strings in here with quotations. So I could say something like equal to 2. Otherwise, well, first of all, we don't need to have a third argument. That's optional. But I could just do something like empty quotations, which would be nothing. Now you notice if I leave off that third argument completely and I press enter, it's going to give me a false. So if you want it to be empty, you have to put in a set of empty quotation marks. And then I can drag this down, and when it finds a 2, it's going to say equal to 2, which is what we did there. Another example, we can use this in an array formula. So if you've got an older version, you can highlight this, type in equals if, and then we can do this entire array at once, equals to 4. If that's true, I'm going to type in yippee. If that's false, maybe I'll put in something like bummer. Alright? And then I can do Control-Shift-Enter on the older versions or Enter on the newer versions, and we can do that all in one array formula. So let me talk about the and the or functions now. Now, the and function and the or functions have arguments, and those have to be Booleans. Booleans are either true or false. Now they can be just false or true, the actual words in Excel, or they can be zeros and ones. Zeros mean false and ones mean true. So the and, let me just put in and of x over here and y. An and is only going to be true if both of the two arguments are true. So if neither of them or either of them are true, that's going to yield a false. They both have to be true in order for that to be true. So this is somewhat straightforward. We can do the same thing with numbers. Remember 0 and 1 correspond to false and true. So we can do the same thing and we get false. The and function always gives true or false, not the numbers, but we can use as operators, as arguments, 0 and 1. The or function means one or the other has to be true. So I can do or, again there's 2 or more arguments, so I could actually have lots of these arguments in there, and the same thing goes with the and function, so I can do or x comma y, and I can drag that down. So if at least one of the arguments is true, then the or function is going to be true, and again we can have multiple arguments other than 2. I'm just going to copy this formula. The same thing goes with zeros and ones, and that's how the or and functions work. Let's go through an example here that's going to integrate some things that we just learned. So I've got a couple of people over here, and maybe they have some sort of subtotal, and we're going to calculate the tax, the discount, and then the total that they have to pay. We are going to give Matt, for whatever reason, he gets a 20% discount. So I've named the discount DISC up here in the name box. I've also named our tax rate TAX up here in the name box. So let's just put in after a discount, I'm going to use an if. So we're going to say if that person is equal to Matt, then if that's true, our discount is going to be 20%, which is our discount of the subtotal. So I can multiply those two. If we haven't found Matt, if our person over here is not Matt, then we have a 0 discount. So I can press enter. So you see Vanessa is not Matt, so Vanessa does not get a discount. If I copy this down, you see that Matt gets a 20% discount, which is $12. And now we can compute the tax. So the tax is going to be the tax rate times the difference between the subtotal, and we're going to subtract off the discount. So the tax for Vanessa is $4. Pull this down. Matt, so after discount, $48 is his subtotal, but he's only taxed $4.80, which is 10%. And then we can finally put the total on here, which is the subtotal plus the tax. And then I can copy this down. So that's an example of how we might use a selection strategy, an if statement, to apply something like this. What if we go a step further and maybe Vanessa and Bob, neither of them has to pay taxes. Maybe they're tax exempt for whatever reason. So let's go up here into the tax formula, and I'm going to put in an if statement. Now we're checking to see if the person is Vanessa or Bob. So we're going to put in an or function, and I'm going to say or. So if B7 is equal to Vanessa, E7 is equal to Bob. Alright, so that part, the or, will give us a true if either of those is true. If B7 is Vanessa or Bob. And then in the if statement, if that's true, then the tax is going to be 0 for Vanessa and Bob. And then if it's not, so if that's false, then the tax is going to be just as it was that we calculated earlier. And then I can close that with the right parentheses, and you see that Vanessa is not charged any tax. I can drag this down because it's a new formula. We need to redrag. And you see that Vanessa and Bob, neither of them is charged any tax. And then finally, we can just make sure that our total is correct. That's how we could integrate an or statement into the tax column here. So hopefully you learned a little bit more about if, and or logical functions in Excel in this screencast. Thanks for watching.